Knowledge is a crazy thing, isn't it? It is something that is simply there without us having to give it much thought. But when we think or make plans, we often attempt to structure it in terms of nodes and edges to define relationships between objects. Let's call this a knowledge graph. Now, if we add a pinch of context to these structures, the inherent knowledge becomes concrete and understandable. In this case, it reveals that our blank node represents our home planet, the Earth. And even though such knowledge graphs are usually incomplete models of reality, they still allowed us to become what we are today and to master future challenges as well. For instance, we are already considering how we could counteract the impending water shortage by searching for it on other planets. But that is not the solution we want to elaborate in this video. Rather, we are interested in how to use knowledge graphs as input to corresponding machine learning algorithms. However, we are immediately facing a problem because most machine learning methods are based on numerical representations which are not present here. Fortunately, there are so-called embedding methods that capture the graph's structure and assign numerical embeddings to the nodes in the graph, which in turn are suitable to apply machine learning applications and therefore also to find out if there's water on Mars. But enough of the universe for now. After all, this video is meant to focus on manufacturing and a project called Teaming AI, in which a total of 15 European companies and universities are designing the collaboration of humans and AI in future production. The main component of the teaming project is called Teaming Engine, which is still blocked by two fixed gears. One of them can be set in motion by adding knowledge in the form of a manufacturing knowledge graph. For example, a painting task can be modeled in which the operator Michael paints vehicles blue in collaboration with the Super Robo 13 Pro Plus. The second gear starts to move as soon as we add numerical representations, which can be used in statistical analysis or machine learning. However, the embedding methods mentioned so far do not account for dynamic changes in the knowledge graph, so we cannot paint cars in green without completely retraining the embedding model first. Since repetitive learning of embeddings is very time and resource intensive, the University of Mannheim developed the tool NaviPy, which enables such dynamic updates in Teaming AI by constructing embeddings for updated or newly added nodes based on the original embedding. NaviPy only needs to be trained once and can then be used on the fly to ensure synchronized representations throughout the entire production process. Now, NaviPy is just one of many innovations that Teaming AI is bringing to the production of the future. If you don't want to miss out on any of those, follow our project and stay tuned.